All right, thank you very much for this opportunity to speak in this great event today. My name is Kalantzi, and I represent OMIKRON Environmental Consultants SA. Our company is a private Greek SME, providing services in the fields of protection, management, and promotion of the natural environment. And we are using integrated scientific approaches and new technology applications. Our main axis of innovations are the primary sector, climate change and natural disasters, and also land and sea environment, including marine forecast, forestry, and biodiversity. We're using several data sources and scientific methods, and our final solutions are technical solutions, including front-end services, back-end services, and automated processes, geoplatforms, APIs, and similar products. The company was founded in 2001, and from that point on, we are always trying to be in the center of research and development and innovation, and thus we play the role of a point of reference on a national, European, and international level. Today, we're going to tell you our story, how we started dealing with solutions for natural hazards up to today. Back in 2015, we thought that we should gather all our know-how regarding forest fires and new technologies. And back then, we developed FIRE, which was actually a desktop standalone application that was aimed in helping safety managers from critical infrastructure, which can be either private or public. For example, it could be a touristic infrastructure, or on the other hand, it could be local authority infrastructure. And we wanted to develop an application that would help the managers manage the risk from forest fires. At that point, our application was using meteorological data collected from station data, and we were providing the FWI, fire weather index, and several five behavior parameters such as rate of spread and flame length, all based to widely used scientific approaches, and also wildfire simulation from also widely used algorithm. And to provide those, we were using fuel type mapping, which was done by aerial photo interpretation from our staff, our personnel. So that was our first approach to create an application that could be used by safety managers to manage the risk from forest fires. From 2018 up to now, we developed this initial approach, this initial idea, and now we are having FIRE Plus, which is a commercial solution, a commercial product, combining cloud and mobile solutions, and more regarding the weather forecast. We're not using the meteorological station anymore. We're using weather forecast models from validated sources such as the ICON forecast model, and also we use high accuracy land cover maps with semi-automated approach to map the fuel types. Apart from that, we use another. I'm not going to go into very technical, a lot of technical details. Either you can send us an text in the chat or an email, and we can discuss further if you want about our technical specifications. But nowadays, FIRE Plus constitutes apart from the information that is needed for a safety manager, it also represents a communication bridge between the safety manager and crews on the field, because you can send text or messages or photographs or a point, the reference point, from the mobile phone to the web platform and vice versa. And you have a lot of other information, very interesting information for the management of risk. Also, the development of FIRE Plus showed us the way of a more multi-hazard approach. And now we are trying to incorporate floods as well in our concepts. And then our concept regarding the multi-hazard approach started with the flash flood wildfire static hazard mapping, and then this hazard mapping led us to the depiction of the exposure of critical infrastructure to these events in a multi-hazard approach. That led us to the production of, let's say, static maps, diachronic maps regarding flash flood and wildfire. Here you can see an example in North Greece, in the urban area of Thessaloniki, where we have mapped the static hazard for floods and fires, and this led us to a bivariate map regarding both phenomena. And this map actually gave us the idea of identifying prone areas, which can now proceed to a more dynamic risk assessment. And that led us to an application called Local Alert, which was targeted to the local authorities here in Thessaloniki. They are supposed to use this application to have good information about the risk, the everyday risk, in very prone areas within their jurisdiction. And then upon this risk, they can manage also their field groups, such as civil protection volunteers. So now we have a web platform showing the everyday risk in certain prone areas, and then we have an application that can be used by civil protection volunteers. And again, the web platform, I mean, the manager and the field crews can communicate with each other depending on the risk and on other parameters. So what we are thinking about the future, depending on the applications and the processes that are already presented, we're thinking now of a more modular architecture. We actually have the funding now to develop a new, let's say, more integrated platform that can share that can provide functions for the general processes of civil protection authorities and also local protection authorities, and this can be also private infrastructure, but also can have slots for applications regarding specific phenomena, such as fires, floods, even earthquakes. Also, we're trying to integrate information that is coming from social media and interpret them into warnings and alerts for specific events, and also information from the web big data. Again, we are also trying to incorporate new technology and new cutting-edge processes and techniques, such as post-disaster mapping, fire detection, hotspots from satellite data, and flood extent zones from UAV and satellite data. And this, we think, it constitutes the future within our solutions and application. Finally, what we have gathered from the actual application of our approaches from local authorities and other actors, it seems that we need to incorporate information from crowdsourcing. We should also try to incorporate machine learning techniques, mainly for the warning or identification and warnings. Also, a more gamified approach seems to be more accepted by the actors, and also trying to develop and make better our modeling and simulations. And that constitutes our whole natural disaster management. I hope I didn't tell you a lot. These are the information. You can always send us an email or give us a ring, and we will be at your disposal for any further clarifications. Thank you very much.
Thank you very much, Ms. Kalantzi, for being precise and punctual with the time. So right now we're going to overall questions and answers. So please unmute your phone and ask your question to the presenters. Who wants to go first?